So far, the two functions that we have explored most deeply are linear functions of the form y equals f of x equals mx plus b, and quadratic functions, f of x equals ax squared plus bx plus c. Notice the similarity between these. Although it may not be obvious at first glance, in both of them we are adding up powers of x. In linear functions, we can rewrite x as x to the first power, and our constant b as b times 1, which is b times x to the 0. And a similar thing in quadratics. Thinking about it this way, we can see that the jump from linear to quadratic meant we included x squared. So the next logical step is to see what happens if we include x cubed. But then next, we'll need to include x to the fourth, and after that x to the fifth, then x to the sixth, and so on. We would need a lot of time to talk about each one individually. So what we'll do is study them all at once. We define a polynomial as a function of the form y equals some constant times x to the power n plus another constant times x to a power 1 lower than n minus 1, and we keep lowering the degree of x all the way down till we get to some constant times x squared plus a constant times x, and finally just a constant. The highest power of x, in this case n, is called the degree. And because n can be big, we don't use a, b, and c, and so on for our coefficients anymore. We use an minus 1, a2, a1, a0. Furthermore, the coefficient of x to the n is an. We call this the lead coefficient. And an x to the n is called the lead term. It's also worth pointing out that we often use p of x instead of f of x because we're talking about a polynomial. But it means the same thing, just a different letter.